Hello everybody, good morning. So today our goal is to go through post-test review. So right now we are in Unit 1 Kinematics. So let's get started. So we'll cover all the topics from all the course topics from the beginning to unit activity, and then I'll try to include here in post-test review. Okay, give me 1 second. Okay, let me go to the next slide. Okay, let's start with this question. So here the question is, what did Galileo discover when he dropped two cannonballs of different weights from the Leaning Tower of Pisa? So in this question, think about what will happen when there is no air friction. Whenever we drop any two or more than two balls from the same height, okay? And then we do have different choice. And then let me get my pen here. So So the first one is the force acting on both of the balls were the same. That's not the correct choice. The time for both of the balls to reach the ground was the same. So that is the correct choice. So if there is no air friction and then we drop any objects with different mass, then they will hit the ground at the same time. So the correct choice is B. Go to the next problem. Physics is explicitly involved in studying which of these activities. So let's start with first choice. The mixing of metals to form an alloy. Probably this is related to chemistry. And the second option, the metabolic function of a living organism. This one is related to biology. Let's go to C. Motion of a spacecraft under gravitational influence. So whenever we heard about gravitational influence, it falls under one of the branch of physics. That's a mechanics. So the correct choice is C. And then you can think about D and E as well, and how can we eliminate those two options as well. Okay. Now we'll move to a next question. Okay, let me read this question. A car accelerates from rest to a velocity of 5 meters per second in 4 seconds. What is the average acceleration over this period of time? So we have to calculate average acceleration, and then we'll use different techniques here, okay? So here, let me write the definition of acceleration at first, and then I'll just write symbol for acceleration. A is our acceleration. Acceleration is change in velocity over time. I'll just write time, the time, okay? And then, so change in velocity can also be written as del V, and time is L del T, okay? Change in velocity. So after that, let's go to the question, okay? Let me erase that. Okay. Let's identify all the information from the question. So here, acceleration from rest means our initial velocity is 0, and to a velocity 5 meters per second, you can see here. This one 0 meter per second, and then the final velocity is your 5 and then meter per second. This one is meter per second. I wrote in a short form, okay? And then I do have time period is 4 seconds per second. So del V is your change in velocity, that is final velocity minus initial velocity over time. Now let's substitute all those values. 5 meter per second minus 0. I'll write meter per second here. Time is your 4 seconds. So 5 over 4 is your 1.25 and meter per second square. Or that is also written as meters per second square. So the correct question is, its acceleration is 1.25 meters per second square. Okay. And then let me show you how we can eliminate all other choices as well, just looking at the unit, okay? So this one, the value is correct, but unit, if you look to the unit, that is the unit of velocity or speed. Unit is incorrect, and unit is incorrect. So the only correct unit for acceleration is in option D. So that is meters per second square. So in that way, we can solve this problem. Now let's go to the next problem. Okay. So here we do have question. A car is traveling along a highway at a speed of 30 meters per second. So we do have a speed. Let me write all the question whenever I read that. Okay. Speed, we do have speed. Speed S is your 30. I'll just write 30 meters per second. Okay. What distance will cover it? 1 minute. So we do have time. Time t is equal to 1 minute. That 1 minute is always your 60 second. I'll just write s for second. Now we have to calculate distance. Distance d is your what? So we know that speed is your total distance cover over time. Okay. Now we are solving here for distance. So multiply both side by time. Time got cancelled. So your distance becomes times speed. Okay, or speed times. So 60 is your time, and then we do have 60, 30, and distance is measured in meters. So here's 1800 meters. So the car will travel 1800 meters in 1 minute. So the correct choice is A. So in that way, we can solve this problem. Now let me go to the next problem. Okay, let me check this problem. The side of rectangles are 6.01 meters and 12 meters. Now this time we have to take significant figures into account. What is the area of rectangle? So to get the area of rectangle, we have to multiply those two sides. So let's do that. So area, I'll just write A for area of the rectangle. Multiply those two sides, 0.1 meters times 12 meters, and the meters times meter is your square meters. And then let's multiply those two. Whenever I do multiplication and all those things, like any calculation graph, I generally use Desmos. Okay, I'll keep that one. Okay, give me 1 second. 12 times. Okay, go ahead here. So this is a Desmos 12, and then times. Where is times? Yeah, 12 times 6.01. So it's, you can see here it's 72.12. Let's go back. Then okay, 72.12. That's what I got. Okay. So let me write it here. Or you can use any calculator, whatever you do have. Okay. 72.12 square meters. Okay. But on this problem, we have to take account of significant figures. Okay. Okay. Now let's go back here. So it has 1, 2, 3 significant figure, and then another side has 2 significant figure. So if we take account into significant figure, whenever we multiply or divide, our final answer will have least significant figure. So 3 and 2, least significant figure is 2. So our final answer will have only 2 significant figure, that is 72 square meters. So the correct choice is 72 square meters. That has only 2 significant figures. So in that way, we can take account into significant figures and use the concept of significant figure to find the area of rectangle in our case. Okay, now let's go to the next problem. So the question is, which value is equivalent to 178 centimeters? So that means we have to convert that 178 centimeters into different units. Yes, it's something like that. Okay, so 178 centimeters. Okay. So millimeters. So whenever you can 1 centimeter is meter is equal to millimeter is your 10 millimeter. Millimeter. Okay, 10 millimeters. So oops, we go back 10 millimeters. So that means it would be around 1780 millimeters. So that choice is wrong. That choice is wrong. Now let's go to C. So 1 centimeter is equal to 10 to the power negative 2 or 1 over 100 meter. So we do have 178 meters. Let's convert that one. Centimeters. That means 178 divided by 1. Let me see. Sorry. 100. Not this is not. Okay, let me erase this. Sorry. Erase. Divide by 100. So meters. Meters. So 178 divided by 100 is your 1.78 meters. So this choice is the correct choice C. And then 1 centimeter is your 10 to the power negative 8 micrometers. So this choice is also wrong. And then so 178 is, if you want to write in terms of kilometer, 178, I'll just write cm per centimeter is your 178 times 10 to the power negative 5 kilometer. So this option is also wrong. So the correct choice is C. Okay, now let's go to the next problem. In this question, we are using the concept of interpolation and extrapolation, I think. So let me read that problem at first, and then whenever I write, I'll explain that problem. Scientists plan to release space probe that will enter the atmosphere of a gaseous planet. The temperature of a gaseous planet varies linearly with the height of the atmosphere. So we do have linear approximation here. The delicate instrument on a board completely fell at a height of 61.5 kilometers. What is the approximate temperature at this altitude? Okay. So we have to calculate temperature at 61.5 kilometers. Okay, and then we are using linear approximation. That means we'll use point slope form of any linear equation. Okay, point slope form. So I'll write here at first point slope form and then point slope form in general way. Okay, point slope form, that is y minus y1 is your m x minus x1. But based on our question, I'll change that equation. So in our y-axis, we have temperature. So I'll replace y with temperature, T minus T1 is equal to m. And in our x-axis, we have depth. So I'll just write D for depth. So our equation will take this form. Okay. Now, first step I want to calculate slope. And I can use any of those points. Okay. Slope is your rise over run. Or you can think as y2 minus y1 over x2 minus x1. So let us suppose this one is your first point, and this one is your second point. Let me write. So first point is your d1, t1. This one is your depth, temperature. So you can write like that. Okay, let's substitute d1, t1 in our equation. P minus t1 is your 147.54. Slope. D minus d1 is your 18.40. So you don't have to write unit, okay? You can write at the end so that there will not be any confusion, okay? Now let's find slope. So slope is equal to y2 minus y1 over x2 minus x1. So y is, but you have to replace your y by temperature. So it becomes T2 minus T1 over D2 minus T1. So let's substitute those values. T2 is your 567, sorry, 567.00 minus T1 is your 147.54, and then D2 is your 78.11 minus D1 is your depth is your 18.40. Okay, I'll calculate that value. Okay, and then I'll write that value. So let me do that. Calculator, let me go to my calculator. Oops. Calculator. So 567 minus 147 is divided by 78.11 minus 18.40. 0 parenthesis close. So it should be around 7.03. Yeah, I'll just write 7.03. You don't have to use correct significant figure. Okay, it's fine for this time. So we got our slope. Now let's substitute slope and then find temperature. So T minus 147.54. Slope is your 7.03. And then we have given that height is your 61.5 minus 18.40. Okay, now I'll solve for T. T minus 147.54 is your, let's subtract at first and multiply by 7.03. Multiply by 61.5 minus 18.40 is 14.3, 43.1 times, okay, times 7.03. It's become 302, okay, 302.99. So it's approximately 303, 303. Now let's add both sides 147. So after that you will add 147.54 on both sides. Okay, 57.54 on both sides. So that means your T becomes 303. So it becomes 450.54. 50.54. So approximately, what is the approximate temperature? So approximate temperature is your 450 Kelvin. So the correct choice is E. So let me briefly review this. At first, we'll use point slope form. Okay, that is your y minus y1 is your slope times x minus x1. Now here our dependent variable is temperature, so we'll replace our y with temperature, and then independent variable is depth. We'll replace x with our depth. Now we'll calculate slope, and then after that we'll substitute the value of the depth and calculate temperature. So in that way, we can solve this problem. Okay, if you have any question, you can ask, you can text me, email me about this question, okay? Now let me go to the next one. Okay, the length of a simple pendulum is directly proportional to square of the time period. So that means length, I'll write length for L, directly proportional to the square of the time period. So that means when you remove the this proportional sign, it will become, we introduced any constant, so it will take L is equal to KT square. So that means L varies directly as T square, T being time period, T being time period of pendulum, okay? And then this type of relationship is always quadratic. Hyperbolic, we will not cover any hyperbolic relation here. Inverse is your, let us suppose if your L is inversely proportional T, okay, 1 over T, directly proportional to 1 over T. Linear with negative slope means I'll say L is equal to negative K times T, sorry, not X, T plus some other constant. Positive is your L is equal to KT plus B. So this, or you can use M as well. So, so that means if any quantity is directly proportional to square root of any other quantity, that kind of relationship is called quadratic. So let me go to the next slide. Okay, let's me read this question and then we'll solve the problem. Let me make diagram as well, okay? Approx moves 60 kilometers east from point A to point B. So before starting this problem, let me clarify about direction. So here, so in your paper, this is your east direction, west, north and south. Okay, now let's make that diagram. Rock moves 60 kilometers east from point A to point B. Let us suppose this is point A, this is point B. So, and then let us suppose rock start from point A and moves to point B, and that is your 60. I'll write km for kilometer. At point A, turns back west. Okay, and stops 50 kilometers away from point A. Okay, so that means it turns back west and stops 15 kilometers away. So let us suppose rock stops here and that is your 15 kilometers. 60 kilometers is your whole, right, like that, from A to B, and this is your 15 kilometers. What are the total distance and total displacement of the truck? Okay, so let's calculate total distance at all. Total distance is your, it moved from point A to B, that is just 60 kilometers plus, and again it come from B to that point. I'll say that point as C, okay, that point, that is your 45 kilometers. 45 kilometers, and then it becomes 105 kilometers. Now displacement is the shortest distance between initial and final position. Here A is our initial position, C is final position. So total displacement is equal to 6, sorry, no, initial to final position is just 15 kilometers. And then both are east, you can see here, C lies on the east from point A. So that is in the east direction. So the correct choice is total distance is 150 kilometers, displacement is 15 kilometers east. Correct choice is there. We don't have to go through other choices, okay? That is our correct choice. Let me go to the next problem. Okay, let me read this question at first and then we'll solve this problem. Okay, let me get my pen. Okay. A satellite is orbiting Earth in an approximately circular path. Okay. So let us suppose this is my Earth. Okay, I'll write this is Earth. Okay. Then I do have satellite here, and the path of the satellite is approximately circular. Okay, and this is the center of the Earth. Let us suppose. And what are the given information here? So we do have time that it completes one revolution in each day, and then we are provided that time. It's orbital distance. Now we do have orbital distance is 22,500 kilometers from the Earth center. So that is the orbital distance, 22,500 kilometers from the center of the Earth. This is the center of the Earth. What is the satellite average speed? Okay, so that is the question. For average speed, I'll just write S. Okay, average speed is your total distance over total time. Okay, total time. Okay. So we have to be a little bit careful here. So satellite completes one revolution. So here the path of the satellite is circular. So we need to calculate circumference of a circle. Okay. Total distance would be circumference of a circle, and circumference of a circle is 2 pi times radius. Okay. 2 pi r. R is your radius of the orbit, and radius of the orbit is 22,500 kilometers. Total time is the time it takes to complete one revolution. That is your 86,400 seconds. I'll just write t at first, and then we'll substitute all those values. So pi, I'll just use 3.14. That is approximate value. Okay, approximate value. R is your 22,500. Okay, 500. The unit for your total distance is your kilometer, and time is your 86,400 second, kilometer second. Now use your calculator and calculate that value. Let me do it real quick in my calculator. 2 times 3.14 times 22,500 divided by 86,400. So it's approximately 1.635, but we can round it to 2 decimal places. So 1.64. 1.64, and then kilometers per second. So in that way, we can calculate average speed of the satellite. So the correct choice is C, 1.64 kilometers per second. Okay, now we'll go to the next problem. Okay, the question is, a bus is traveling with a uniform acceleration of 2.75 meters per second. If the initial velocity of the bus is 16.5 meters per second, what will its velocity be after 9 seconds? So we have to calculate its velocity after 9 seconds. So to solve this problem, as you know that we have went through 3 different equations of kinematics in our first unit. So I have covered those in our live session. If you haven't gone through it, I'll strongly suggest you to go through those 3 equations. So it will be very helpful to solve these types of problems. So let's identify all the information provided, then we'll solve this problem. Okay. We have uniform acceleration. I'll write A for acceleration. 2.75 meter per second square. Initial velocity is given V0, 16.5 meter per second. This is the short form for meter per second. Okay, don't get confused. What will its velocity? Final velocity we need. What? And then time is given 9 seconds. 9 seconds. So if we use velocity equation, that is B0 plus AT. A is your acceleration, B0 is your initial velocity, T is your time. Now here, if we use this velocity equation, we can solve this problem. So we have to calculate velocity after 9 seconds. So B is your B0 plus AT, 16.5 plus acceleration is your 2.75, and then T is your 9. And then I want to write my unit at the end. Okay, so velocity is your meter per second. So let's calculate that value. And then so I do have 16.5 plus 2.75 times 9. So it's 41.25. So if we round it to 3 significant figure, it will become 41.3. So final velocity is your 41.3 meter per second. So that correct choice is B. So in that way, we can use velocity equation, that is one of our kinematic equation, to solve this problem. Okay, now let's go to the next problem. Okay, so here, let me read this problem. Whenever I read the problem, I write all the key information as well, and then I'll solve this problem. Okay, okay, let me get my pen. A stone is dropped from a tower of 100 meters above the ground. Okay, that is one information provided. The stone falls past ground level and into a well. Okay, it went into a well. It hits the water at the bottom of the well 5 seconds after being dropped from the tower. And then we have to calculate the depth of the well. And then we have given G is your negative 9.81 meter per second square. Okay, let me make a tower at first. Okay, don't go to my figure. Okay, it's not that much good. Let me see, this is a ground. Okay, ground, so that we'll have some clarification. Ground, so this is a tower. Tower is 100 meter, 100 meter. Then we do have a well here. I'll make a well here. Okay, well, well means I'll make like water so that it would be easier to identify. Well, this is your tower. This is your well. Okay, okay, this is 100 meter, and then let's collect all other information. So time is 5 seconds, and then bottom of the well. So stone drop. Suppose this is stone. Okay. Now we have to calculate this distance. I'll say this, but this vertical position, height, we have to calculate that vertical position. Okay. Vertical displacement, sorry. And then once we get that vertical displacement, we can solve this problem. And all other information are provided here. So that vertical displacement is from here to here. Let's see. We do have that information on that meters. Okay. Stone is dropped from a tower. So whenever we drop initial position, no, let's forget everything. Let's start in this way. So here we are calculating displacement. So we are using displacement equation. Okay, let me write displacement equation at first. X is your x0 plus b0 t half at square. Okay, let me clarify all those variables here. X is your final position, x0 initial position, b0 initial velocity, a is your acceleration, t is your time. But we are talking about vertical position. Replace your x by y. Okay, x0, y0, b0 2, and then replace your a with g. Since the stone is falling under the action of gravity, we'll replace a with g, 1 over 2, and then g t square. Okay. Now let's plug in all those values, and then we'll calculate our vertical position. So initial position 0, initial velocity is also 0. So y, that is our final position, is your 1 over 2 gt square, 1 over 2 negative 9.81, time is your 5 square. And then the unit for your displacement is meter. I'll write it here. And then whenever you calculate your displacement, at the end you can ignore your negative sign. Okay, so that is, you are calculating height, you can ignore your negative sign. 5 square is your 25. 25 times 9.81, then divided by 2. So it becomes 122.625. So 122 point. I'll write everything at the first in the beginning. Okay. 6.2, also 6.3 meter. 6.3 meter. And then we ignored negative sign. So that is the height from the top of the tower to the bottom of the well. Now the question is, we have to calculate, let me see, depth of the well. So we need to calculate that height, that depth, sorry. Okay, depth. I'll write that as D, depth, okay. So depth of well is, so if we subtract 100 meter from that total height, we'll get the depth of the well, sorry. 22.63 minus 100 meter. So it becomes around 22.63 meter, and then the approximate value is 22.5 meters. Okay, yeah. 22.5 meter. We want to write our values in 3 significant digits. So that would be our depth of the water meter. So the correct choice is A. So in that way, we can calculate depth of well. I know this problem is little bit difficult. We have to modify. Uh, we have to modify our displacement equation in the given situation, and then first we have to calculate total vertical height, total vertical displacement, and from where we have to subtract tower so that we can get the depth of the well. Okay, now we'll go to the next problem. Okay, let me read this problem at first, and then we'll solve this problem. A ball is released from a hot air balloon moving downward with a velocity of negative 10 meters per second. So we have given the initial velocity and a height of 1000 meters. Okay, we do have height as well. How long did it take the ball to reach the surface of Earth? So how long? So we have to calculate time here, and then we have given g negative 9.8 meter per second square. Let me make a picture and write all those information, and then I'll solve the problem. Okay. Okay. Let me write the balloon network. Let me make a picture of. Let us suppose this is a balloon. And this is a ground. Ground balloon. BALLOON balloon. Okay. The height. This height is it's given. Okay. This is a straight line. Okay. This height. So let's see from here. Okay. This is your height. It does not matter. Okay. So this is the height of the balloon. 1000 meters. Okay. And then initial velocity is given. V0 is your negative 10.0 meter per second. G is given negative 9.8 meter per second square. So acceleration due to gravity is given, initial velocity is given. So in this problem also, we are working on a height, and height is your, think like vertical displacement. So you have to use displacement equation. So let me write displacement equation here again. X0 plus B0t plus half AT square. I'll replace X with Y like the problem we solved before. B02 plus half, and I'll replace A with G, that is acceleration due to gravity. Now let's figure it out all the values. So initial height, that is Y0 here, 1000, and final height is your here on the ground. That is your final displacement, that is your 0. So this quantity is 0 here. So 0 is equal to Y0, that is your initial position, is your 1000. B0 is your negative 10, and then time plus 1 over 2, G is your negative 9.8. Okay, let's simplify this little bit. Okay, so it become, I'll write it here. Okay, after that, let's go here, write it here. We do have more space here. So 0 is equal to 1000 minus 10t. 9.8 divided by 2 is your 4.9. So positive, negative, negative, 4.9 t square. So I'll write as equation 1, okay? So as you can see here, we got an quadratic equation in t, okay? Quadratic equation in t, and we have to solve this equation to get the value of time. And the easiest way to solve this quadratic equation is to use Desmos. Use Desmos and graph that quadratic equation and look for the point of intersection. That means where that graph intersect your x-axis. Okay, from there pick your time. But as your time is always positive, we'll use positive values. Okay, so so it's 1. So 0 is equal to 1000 minus 10t minus negative 4.9 t square. Okay, let me go to the Desmos. I'll keep it. Okay. Okay. Let me go to the Desmos. I'll open Desmos here. Okay. So you can go to that Desmos. Okay. I'll reload this side. Okay. You can go to desmos.com calculator and then you can graph it from the beginning. So let's check it out. So it's 0 is equal to, just pick right hand side, or you can pick whole equation. It does not matter. Okay. 1000 minus 10t minus 4.9 t square. Yeah, let's do like that. 1000 minus 10. I'll replace all t with x. Okay. It's just the variable. Minus 4.9 x square. Square is here. Square. Let's graph it. Okay. Okay, now we got a graph. Yep. So did you see? We got a graph and then it crosses at 2 points here. So this point is a 13.320 at time is equal to 13.302. The equation has 0 value. Okay, so the graph has a 0 value. Sorry, and negative 15.343. But here time cannot be negative, so we'll exclude that value. So you can see from here. Okay, so the time would be 13.3 seconds. So that means, let me go back, at 13.3 seconds, the ball will reach the surface of the earth. So we got that from, okay, let me get my pen here again. So from Desmos, we got time is equal to 13.3 seconds. So basically we got like that, 2 points. Okay, we got 2 points. This one is 13.3 comma 0, and this is negative 15 point something. We have to exclude that because your time cannot be negative. So here our solution for t from this equation is your t is your 13.3 second, and then our correct choice is C. At 13.3 second, the balloon will reach the surface of Earth. So I want to thank you all for watching this video. Have a great day. Thank you very much.